Hey guys, so here are the notes for 6.3. We are now going to be talking about similar polygons. So we are going to use the idea of proportions and using cross multiplication to solve. For this section 6.3, I am going to cut this probably into 3 parts. I know that seems a lot, but I do want to cut these videos down a little bit shorter. So let's just talk about the objective here. So we're going to use proportions, as we talked about, and we did in 6.1 to identify similar polygons. So in this one, we're going to talk about our lovely vocabulary and do example 1 for this first part. Okay, so what I would suggest, pause this video and just write down that entire definition there for similar polygons. Okay, what are similar polygons? Well, in order for polygons to be similar, corresponding angles are congruent and corresponding side lengths are proportional, okay? Let's talk about some symbols here, and then we'll talk about angles being congruent and side lengths being proportional. Okay, so you're going to see this symbol here. This is what we call the similar symbol. It's just like a little squiggly line. That's it, squiggly line. Okay, and then our next thing is our congruent symbol. This you should know from past things in geometry. If you don't remember, that's okay. That's why we're talking about it. So congruent has that same that same squiggly line, but then has the equal bar underneath. So that means congruent, okay? So what they mean by the angles being congruent, okay? So let's say we have E and A. Those are congruent angles, meaning they are the exact same amount. And then we'll have G and C be congruent, okay? Then F and B, and then we'll have H and D. Now you might notice like the lines that I'm creating. If the angles have the same lines, that does indicate that they are congruent, or they are the exact same amount, okay? Now let's talk about corresponding side lengths being proportional. Let's say they gave you that, EF is, let's say 4, and AB is 6, okay? And the idea of being proportional, it just means that we would have like 4 over 6 to indicate that FE and BA are proportional. So you can create a fraction, okay? And of course we can simplify that to become 2/3. Now, one last thing we do need to, and make sure you are writing down this in that solve for similar polygons. Another idea is what we need to talk about, a similarity statement, okay? So I'm gonna write EGHF is similar to ACDB, okay? Now, how am I able to write this? Well, the idea, and we're going to do this in our next example, your congruent angles need to line up. So notice that E and A, they're congruent angles. They're both the first letter in our similarity statement. So that's indicating that they are congruent. We know that G and C, they are congruent angles, so they need to line up. And then H and D are congruent, and F and B are congruent, so they need to line up. This is also true when we are doing our proportional sides, or side lengths that are proportional. Well, we said that, how did I write this? I guess FE, right? We have FE. And so that means BA is the same side, or proportional side, okay? So you do need to make sure you line up some things. So this is what we call a similarity statement, and we will do more of these in the videos, okay? Definitely please make sure you write this down, because you're gonna see this a lot, really throughout this unit, okay? And remember, if I'm going too fast, make sure you pause the video, write things down, or you can also rewind. Okay, scale factor. Once again, pause the video and just write this down. Okay, so scale factor is the ratio of the lengths of 2 corresponding sides. So let's say, for example, going back to similar polygons, and we had those two figures, okay? Let's talk about FE and BA. Those are corresponding sides we can write a fraction. Remember, FE was 4 and BA was 6. And of course, you simplify it, so 2/3 is what we would call the scale factor. Now, in order for two polygons to be similar, all corresponding sides have to have the same scale factor. And that's what we're going to get into a little bit later on when we need to talk about that, indicating if two polygons are similar. Okay, our last thing, perimeters of similar polygons. Once again, pause the video and write down this definition. So perimeters of similar polygons just means the ratio of the perimeter is equal to the ratio of the side lengths, the scale factor. So basically you would just say the scale factor equals the perimeter of one polygon over the perimeter of the other polygon, okay? So you'll see that basically in our example 4 when we talk about the perimeters. So you will have to watch later on, and I'll refer back to this definition. Okay, so now let's go ahead. Let's do our first example. So on this one, in the diagram, they are telling us that triangle ABC is similar, remember that little squiggly line, that means similar, is similar to triangle DEF. Okay, let's take this one at a time. List all pairs of congruent angles. Now remember, as I said, congruent angles, when we have our similarity statement, they need to align. So let's look at this. We have A, right? And I'm going to color code this because I think that's always a great idea. We have A. Notice what is the first letter of our second triangle. That is D. So that means A and D, they are congruent angles. Okay, B is our second letter. So now we gotta look at what's the second letter in our second triangle. That's E. So B and E are congruent. And then lastly, we have C. Well, the last letter in our second triangle is F. So C and F are congruent. So now we can write all of this in our part A of the solution. So it says solution. In part A it says angle A is congruent, remember that's the congruent sign, to angle blank. Well, we said that angle D was congruent to it, okay? Because they are both the first letters of each of the triangles. Okay, angle B is congruent to angle blank. Okay, go ahead and maybe fill this in. Okay, hopefully you said that angle E, right? Because they are both in the same position there. They're both in that second spot. And then lastly, what about angle C? Go ahead and put what your guess is for that one. Hopefully you said angle F, okay? So this is nice and easy. As long as you kind of look to see what the similarity statement is, the letters will tell you where it goes. Okay, part B now says to check that the ratios of the corresponding side lengths are equal. Okay, so we kind of can use what they gave us here. So they said AB over DE. Now, how do they know it's going to be AB over DE? They're kind of already giving it to you. However, sometimes that might not be the case. Well, notice that in our first triangle, AB are the first and second letters. In our second triangle, DE are the first and second letters. So you need to follow the order. So let's look at AB. So AB, I'm going to use shapes here. AB is 10 and DE is 15. Now make sure you simplify if you need to. So we got to think what number goes into 10 and 15. That's going to be 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So we got 2/3. Okay. Now BC and EF. If we notice, BC is the second and last letter, and E and F are second and last letter. So they match up. They pair up. always match up. Okay, BC, I'm going to use a circle. That's 8. And EF is 12. Once again, we can simplify a fraction. Always do that so you know if, the corresponding sides have the same scale factor. So 4 goes into 8 twice, and 4 goes into 12 3 times. Okay, we're doing so good so far. And our last one is CA, and then FD. So we got 12 over 18. And once again, if you look in the letters, we go C, and then A, and then F and D. So what number goes into 12 and 18? That's going to be your 6. So 12 divided by 6 is 2, and 6 goes into 18 3 times. Now notice that the ratios are all the same, 2/3, 2/3, 2/3, okay? That is what we would call our scale factor, okay? In order for polygons to be similar, that means the corresponding sides all have to have the same scale factor. If one of these did not have the same one, then these two would not be similar polygons. So be careful, okay? Now they're telling you that the triangles are similar and you have to do things, then you got to be careful that each thing is the same, okay? Otherwise, if they're just asking you to determine if they are, it is possible that the polygons are similar or they might not be. But we'll talk about that in a little bit. Okay, last thing is to write the ratios of corresponding side lengths in a statement of proportionality. Okay, all they're asking, and I know this sounds like so much, okay, but really it's very easy. Where we see the AB over DE, we write that. And then where we have BC over EF, we write that. And lastly, CA over FD. Okay, this is just saying that all the sides have the same scale factor. Okay, so make sure you might want to underline this statement of proportionality because you're going to see that phrase in your homework and you want to make sure that you understand what that is. So definitely when you go to your homework, refer back to this example 1 part C when it talks about statement of proportionality. Okay, so this is going to be the end of our part 1 of 6.3. Make sure if you need to, watch part 2 of the 6.3 note.